Okay, so this question is asking us to reduce the given reducible representation for the motions of a water molecule to its irreducible representations. And we're given a couple things here. First of all, we have the reducible representation and its table. We also know how the molecule looks and its axes, though those aren't as relevant to this specific question. Finally, from Appendix C, in the textbook, we can find the character table for C and V, and specifically C2V groups, which is our point group for this water molecule. Now, to find an irreducible representation, we need a couple things. First, we need to find the order, which is the number of operations for the given point group. So we can see from our reducible representation that we have 1 E operation, 1 C2 operation, 1 sigma V XC operation, and 1 sigma prime V operation. So together that means we have 4 operations, which gives us an order of 4. Now, why does this matter? This order matters because in order to find our irreducible representation, we're going to take our reducible gamma values here, and we are going to multiply these values by the identity values in the character table, so which is right here. Now, looking at A1, so the A1 irreducible identity, we see that we start off with 9, which comes from here in the reducible table, 1 because we have 1 E operation, and 1 from this larger character table. And we multiply each of those together. And then we do this step for each of our symmetry operations. So we have -1 as a gamma value for C2. We have 1 C2 operation, and we have 1 as the A1 value for C2. Again, 3 comes from here, 1 because we have 1 sigma V, and 1 from the character table. Finally, we have 1 from the gamma value, 1 because there's 1 sigma prime V, and 1 again from the sigma character table. So we go through and we do this and get a sum of these values. In this case, we get 12, and then we have to divide by the order to actually find this irreducible representation. So 12 divided by 4 gives us that we have 3 A1. Okay, so then we go through and we just do this for each of our operations and our representations in the table. And from this we find that we get 1A2, 3B1, and 2B2. So in order to write our reducible representation, we know that our reducible representation will be 3A1 plus 1A2 plus 3B1 plus 2B2. And this helps us going forward with determining different properties of the molecule